Moving along, we're almost 2 sections away from the end of this chapter. Pretty easy, succinct chapter. We're going to the method of common bases. So we're still with exponentials, except now we're going to look at problems where the bases aren't the same. So what does that mean? So if I asked you to solve 2 to the x is 16, you'd think that's pretty easy. You'd shoot right out that x is 4. It's a known fact. But how about this? What about 8 to the x equals 16 to the 3x minus 2? Now we're stuck with a really hard problem because you're going to start guessing numbers like, well, 8 squared and that's 16 and 3 and now I'll put a 2 and it can get quite tedious if you're going to guess and check. So what we want to do is we want to look for a common base. Oops, spelled common wrong. There we go. So here's the number 8 and here's the number 16. They're the bases of the problem, but they're not common. One's an 8, one's a 16. But what we think is that 8 can be rewritten in base 2. In fact, it's 2 to the third power. And then we still have the x. Because remember, if I wrote 2 to the third and then the x on the outside, a power to a power means we multiply. So I'm going to do the same thing with 16. I chose 2 as my base because 2 to the fourth can get me 16. And then I still have the 3x minus 2. Well, now I can solve quite easily because I'm trying to get one side to equal the other side. Well, I've already got the bases alike, so now I have to work with just the exponents. So this left me with an exponent of 3x on the left, and on the right it left me with an exponent of 12x minus 8, because remember I have to distribute. A power to a power means to multiply. Doing some very simple math, move the 3x over, move the 8 over, and we found out that the answer to this problem was a number we probably never would have guessed. The x is 8/9. So again, a quick lesson today. So here's a couple of examples to practice. We want to solve here, and we want to find a common base. When we look, we have a base of 9 and a base of 27. Well, what we're going to do is we're going to take that 9 out, and we're going to realize that is really 3 squared. So we're going to take that 9 and replace it with 3 squared. Likewise, we're going to take this 27 and realize 27 is 3 to the third. And so we'll replace that with 3 to the third. We still have that in parentheses. So now that our bases are the same, we simply have to deal with the exponents. Multiply, we get 4x plus 2 equals 3. Little solving. And voila, that's the answer to this problem. X equals 1/4. All right, so when we look at this third problem here, let's give ourselves a little room. We have to think what's a common base between 125 and 1/25. Well, the common base is 5. 5 goes into both of those. So we have to rewrite 125. So 125 is really a base 5 raised to the third power. All right, so I'm going to replace that 125 with 5 to the third. 1/25 can be rewritten as 5 to the negative 2. So I'm going to replace that 1/25 with 5 to the negative 2. I have my common base of 5, so now I can solve. Common base is 5. I'm left with an exponent of 3x on one side, and on this side, after I distribute, I get negative 8 plus 2x. A little math, and voila, x is negative 8. Getting the hang of it? Not hard. All right, so what's my common base going to be with a 2 and a 64? That's right. You have to think 2 is the common base because 64 is 2 to the 6th power. So I can replace that 64 with 2 to the 6th power. I now have common base of 2. Cross it off. X squared minus 3 equals 6. Well, this isn't that hard. X squared equals 9. So here there are two answers. X can be a plus or a minus 3. Because remember, when you have something raised to the second power, it often means there are two answers. All right, so the last one is not that hard. They want us to find the area of a square. So you have to think an area of a square is you take one of the sides and multiply it by the other side, better known as side squared. Well, if I could find out how long a side is, that's easy. So we have a point right here where they meet, these two exponential curves. Shocking, exponential curves in the exponential section. Well, the one curve is y equals 4 to the x plus 5 halves, and the other one is y equals 1/2 to the 2x plus 1. And if we remember where they meet, is going to be the point. So I'm going to take that and I'm going to set them equal to each other. It's looking like problems 1, 2, and 3. I have to find a common base. Well, a common base between 4 and 1/2 is 2. Well, 1/2 can be rewritten as 2 to the negative 1, and then I have 2x plus 1. And then 4 can be rewritten as 2 squared, and then I still have x plus 5 halves. Awesome! The bases are the same. Now I can just solve the exponents. Little math here, we get negative 2x minus 1 equals 2x plus 5. Add the 2x over here, becomes 4x minus 6. So the x value is 4, change that. The x value is negative 6 divided by 4, which is negative 3/2. Well, that's awesome. But I don't know my y value. Do I need it? No, because if I know this is a point, it means I went over 3/2, but since this is a square, I must have gone up 3/2. So now the final step here, what they wanted me to do was find the area of this lovely square. So the area must have been 3/2 times 3/2. 9/4 units squared.